Hello there and welcome to A2 Maths. We're on June 2018, paper 1, and here we're looking at question 10, the differential equations question. So the height above ground h meters of a passenger on a roller coaster can be modelled by the differential equation dh by dt equals h cos 0.25t divided by 40, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, sounds as if that's an initial condition to me, so t equals 0, h equals 5. We may need to substitute in at some point. Show that h is equal to 5 times 0.1 sine 0.25t. So let's write down what we're trying to work out here. dh by dt is equal to h cos 0.25t over 40. Now what makes this a differential equation is that there is h and t on the right hand side. You can see h here, capital H here, t over here, and there's dh by dt in our differential bit there. So what we need to do is we need to put all our h's on one side, all our t's on the other side, and then we can do some integration. So how would we move h onto the other side? Well, we can divide by h. We'll write it as 1 over h dh, and then treating dh by dt as a fraction, we can times the other side by dt. So we're going to times by dt, and we're also going to divide by h. Those are our two moves from line 1 to line 2. So we're going to have cos 0.25t over 40 times by dt. Now what we can also do to both sides to now start to solve these differential equation and get rid of the dh's and the dt's is to integrate both sides. Okay, so now we're at a point where we're solving the differential equation. On the left hand side we've got 1 over h dh, that is obviously ln of h. And then on the right hand side, well, let's pull this 1 over 40 out to the front. We're now integrating cos. Remember that we've got a little circle of life here that tells us what to do when we're integrating sine or cos. We're at cos. This is differentiation, the way that I've put the arrows, so we need to go backwards, back to sine. So the answer is going to be sine of 0.25t. And remember, when we do integration, we divide by the scale factor multiple inside the bracket. So it's divide by 0.25. When you divide by 0.25, you times by 4. So 1 over 40 times 4 leaves us at 1 over 10 plus c. Now remember, when you solve a differential equation, you only need to plus c on one side. What we'll now do then is we'll now plug in t equals 0 and h equals 5 to work out what this plus c is. So it's going to be ln 5 equals 0.1, we'll write it as 0.1, this 1 over 10, it's the same thing, sine of, well, 0, sine of 0, well that's just 0 anyway, so that just all disappears, and then plus c, so c is ln 5. Okay, so what do we have then? We have ln h equals 0.1, looks good for the 0.1 there, sine 0.25t, looks good so far, looks very similar to what we're trying to work towards, and then we have plus c, which is plus ln 5. That would make sense because we've got 5 at the front there. Let's now get rid of the lns from both sides. Now, to get rid of the ln from the left is easy, we just e both sides, so we've got h that's left on the left, but on the right hand side we're going to have to e to the power of everything. You can't just e to the power of individual things, you have to do e to the power of the whole of one side. Sometimes it's nice, sometimes it's not so nice. Now what we can do with this e is we can separate this addition. When you separate addition on indices, you effectively multiply with the same base number. So it's 0.1 sine 0.25t, and then to separate this plus ln 5 we times e to the ln 5. Remember that when we times indices with the same base we add the indices. This is just the reverse of that rule. And whenever you have e of a ln, you can just cancel those two out effectively. They're inverse functions with each other. So it's 5e to the 0.1 sine 0.25t. So there we are. That's how we answer part A there. Moving on now to part B. State the maximum height of the passenger above the ground. So this is our function for h, so let's write that out, it may be important. 5e to the 0.1 sine 0.25t. Okay, well the maximum height, we want to maximise this function. The maximum value that sine can be is 1. No matter what happens inside the angle, sine has a maximum of 1. So the max of h is going to be when sine is 1, so it's going to be 5e to the 0.1, which comes out to be 5.526. So let's round that to 3 significant figures. It was 525 on the decimal, so it's going to be 5.53 meters on the roller coaster. Doesn't look like the roller coaster moves up too high then. The passenger reaches the maximum height for the second time, t seconds after the ride starts. Find the value of t. Okay, so we want to find, when it's a maximum height, sine of 0.25t needs to equal 1, and we want to find the second solution of this. So is there a boundary for h? No. What we'll do is we'll say that t is in radians. You can only ever do differentiation and integration of sine and cos and tan when t is in radians, so it must be the case that t is in radians. So therefore 0.25t, well, when does sine have a maximum point? It goes up, down, up. This is at pi by 2, this is at 2 pi, so it must be at 5 pi by 2. So the second solution must be 5 pi by 2. This is effectively 1/4 t equals 5 pi by 2. So t must be 10 pi. We can turn this into seconds if we want to. That's just times pi by 10, 31.4 seconds. So there we are, that's the answer for question 10 there. 8 marks in total for question 10. Let's now move on to question 11.